All right, guys, surface area. This is kind of round two of the discussion, and this, in my opinion, is it's a tough concept. Last class, we were talking about how surface area, if we're really just trying to keep to just the basic concept, none of that has changed. We still just need the area of all faces added up. So if you think you can find the area of each of the faces involved with your pyramid, you are more than welcome. Just realize a pyramid every single time is going to have a shape on the bottom. Here, I'm going to go ahead and tell you that this is a square pyramid. So every time you're going to have a shape on the bottom and then a certain amount of triangles. That's it every time. Just realize you got to be careful. If you want to find the area of one of those triangles, you're going to need the base, and you're going to need the height of that triangle. Now, the height of that triangle is not this measurement here. It's not the height of the pyramid. It's different. It's not this measurement down here. That's called a lateral edge. You want to find the height of the triangle. It's tough to draw for you, but it's got to be this piece going down the middle of the triangle that ends up being a right angle there. That is the height of this triangle, all right? And it's slanted off the side, so the name that this has been given is called the slant height, but it's the height of the triangle. The letter that's given to this is L. So like base gets B. The height of the pyramid would be H, which is different than the height of one of these triangles, which is slanted off to the side. So again, you're okay if you want to find the area of just one of the triangles and multiply by how many of those triangles you have. Just don't forget about the base here. This may be one of those times you want to come in with what's called the surface area formula. The surface area of a pyramid can be found by doing 1/2 times capital P times L plus capital B. But like I was worried last time, this formula has some things that can get us in trouble. So we got to be really careful. All right. That capital P, we were presented with that last time. P stands for perimeter, but what are we finding the perimeter of? It would be the perimeter of the base. So you would want all of these sides of the base added up, and that's what would go in for P. L, that's our slant height. So this formula, this is a clever way of finding the area of all of the triangles in one step. Because normally a triangle is 1/2 times base times height. Well, this is 1/2 times all of the bases times one height. So this takes care of all of the triangles. You got to be careful here. Capital B, that stands for area of the base. So this capital B's got to turn into some formula every time. Here, we're going to want to find the area of the square. So capital B is going to turn into side squared. If it was a pentagonal pyramid, the area of the base is we're going to use 1/2 AP, which is the area of a regular pentagon. So if we take this problem, let's maybe put some numbers in. If I have a square pyramid, let's say that this measurement here was 8. What if I told you that the height of the pyramid was 3? Could we find everything we need? This is a bit of a tricky problem. This is maybe one of the more difficult versions of this problem. So just understand, if I want to find surface area, I want to do 1/2 times the perimeter of the base times the slant height plus the area of the base. We got to try and see how many of these pieces of information do we know. I think I can find the perimeter of the base. Since the base is a square and I gave you one of the sides, the perimeter is going to be 8 added to itself 4 times. So 8 times 4 is 32. That's the perimeter of my base. I think I also got the area of the base pretty quickly because it's a square. Base is 8, height is 8, 8 times 8, 64. I got 2 of those pieces pretty fast. Problem is slant height. I don't have that. I have the height of the pyramid. This measure right here is 3. That's not what I want. I want this over here. And just remember, if I've hidden something from you, I'm always going to hide it from you using a right triangle. Here is a hiding right triangle in the middle of that pyramid. I know the height is 3. I configure this base here, since I know all the way across is 8. This would be halfway across, which is 4. If I do a quick Pythagorean theorem problem, I'll go ahead and let you know the slant height of this pyramid is going to be 5. This is going to be a 3, 4, 5 triangle. So there was my missing piece. And then I can start working. 32 times 5 is 160, and half of that is 80. If I add 64 to it, I get 144. This is an area, surface area problem. If these were all meters, then my answer would be meters squared. I think here the formula was helpful. Again, you gotta really be focused on what it is you're trying to find. All right. I think the formula over here is not only important, but it's almost extremely necessary. Breaking this down into a net is much more difficult. We have a circle on bottom, which isn't bad, but then this lateral area is always going to be a portion of the circle. All right. Here's the formula we're going to use. We're going to use pi RL plus pi r squared. Well, this takes care of the circle on the bottom. This will be a formula to find the lateral area. So some of the problems you're going to get, they might ask you for surface area. You could also be asked for lateral area. So let's just understand over here, if I want lateral area is everything but the base. If you want lateral area, you just have to do this part of the formula. That is lateral area. If you add in the base, you get total surface area. If this part is the circle, then this part is my lateral area. If you're doing one of the problems, you're on the way to doing the other. So if I knew, and again, I could hide some stuff from you. This is the height of the cone. Here's the radius of the circle, which put together makes a right triangle. I'm going to go ahead and just give you the values. Let's say that's 10. Let's say my radius is 5. So the slant height is this measurement that goes down the side of the cone. If I want to try and work through that problem there, I just need to do pi times the radius, which is 5, times the slant height, which is 10. That's my 10. That's a beautiful 10. Plus pi times the radius squared. Taking this straight from this formula right up here. So be prepared also to answer in terms of pi. So this 5 times 10 would be 50 pi, plus 5 squared is 25 pi. So my surface area, if I put those together, I get 75 pi. The lateral area would only be this. Get rid of the base, and see I've already done the work for my lateral area here. The lateral area over on here would be this portion. The lateral area would be 80 meters squared. All right, so don't think you're being, if they ask for surface area and lateral area, you're not really doing two problems. You're doing one problem that helps you find both pieces. Okay, so please be careful with these problems. If you don't have the formulas, you really have to have a great grasp on what's going on. And make sure you're in class because we want to try as many of these as possible. So, good luck.